Professor,
Yes.
you say you're starting from scratch. So you're saying.
I'm starting from scratch. And please, what's that? I just need to, okay, I'm starting from scratch. And this is chapter 2. Which is the review of probability. So, all of you might be familiar to some concepts and formulas and expressions that we'll see today, because all of you had statistics, right? Because that's the prerequisite of this course. If you don't remember any of the expressions or any of the concepts that I will explain today, that's fine, because I am, as I already said, I'm starting from scratch, and you will learn everything that you need to learn in this course to do well. So, first, let me emphasize that you all are part of a bubble, right? This bubble can be Baruch College students or students in NYC schools, right? Maybe students on Earth, right? And so on. But you guys are part of a whole, right? So that whole is known as population, right? And you guys are part of this, right? Since you are part of this, you are a sample. Right? And as you already, as I already said, sample is a part of the population. So we can have different populations, right? And depending on the questions that you guys are trying to answer, maybe you want to see whether, let's say, reducing class size in general in all schools improve students' performance. Or maybe you are specifically interested in, let's say, students in NYC schools, right? If I reduce class size in NYC schools, does students do better in tests, right? So bottom line is that we can have many different populations, and you can take lots of different samples from the populations. Right? Sample should be taken randomly from the population to be able to draw plausible inferences about the population parameters. Now let me say a few words about random variables.
Professor, can you scroll up for a quick second?
Yes.
Got it, thank you.
Let's say your letter grade in this course. Do you think your letter grade in this course is a random variable? It is a random variable. Since you could get any letter grade from A to F, right? Right now, you don't know, but there are possible outcomes, but right now you don't know what exactly will be your letter grade. That makes your letter grade at this moment in this course a random variable. In this course, we have 80 students, right? Guys, please mute yourselves unless you are asking questions, because then it's somewhat distracting. So we have 80 students. So that means that we have 80 different random variables, right? Because letter grade of every student is a random variable that can take any outcomes from A to F, right? So let's simplify. Let's simplify and say that so assume that we have only the following letter grades. Say we have A, we have B, we have C, we have D, and we have F, right? So that means that every student can get any letter grade out of these 5 possible outcomes. 5 possible letter grades. Okay, even though we don't know exactly what will be our letter grade, we might have and we do have our expectations. So these letter grades are associated with probabilities. Let's say student 80, not 80, let's say student, let's say 67 has the following distribution of letter grades. A, B, C, D, F. This is for 67th student, and that's the probability of letter grades. Let's say the student expects to get a with let's say 0.20 probability, expects to get B with probability, let's say 0.15, expects to get C with probability, let's say 0.40, let's say expects to get D with probability 0.10, and the remaining will be F, right? So we have this is 0.50, 0.70 plus 0.15 is 0.85, so 0.15 is remained, right? So, so 0.20 plus 0.15 plus 0.40 plus 0.10 plus 0.15 should add up to 1. I hope it does. This is 0.15, 50, 70, 85, and then this is 1. But this is probability distribution of letter grades for this particular student, 67th student. But everyone has their own probability distributions of letter grades, right? What will be different? So let's say if I let's say wanted to give you an example of the distribution of letter grades for, let's say 55th student, distribution of letter grades, what would be different? Can you guys tell me? And now you can unmute yourselves and you can answer.
The probabilities will be different.
Probabilities would be different, right? So because it is very unlikely that 2 individuals have the same expectations of the how likely are these letter grades, right? So the only difference would be in these probabilities, right? So everything else would be the same, right? A, B, C, D, and F. And here it would have, let's say 0.05, 0.10, let's say here we have 0.50, let's say here you have 0.15, and here is what? This will be 1 minus the sum of, I'm just writing this for you guys, right? So that you know how do we get these numbers.
Sorry, can you scroll up for a quick second?
Yes, of course.
It's lagging. Thank you.
So now you have an idea of what probability distribution is, right? But random variables are of two types: discrete random variables and continuous random variables, right? What is the difference between discrete random variables and continuous random variables? Discrete random variables take countable number of possible outcomes. But for continuous random variables, the number of possible outcomes is uncountable. So guys, then let me ask you, is your letter grade a discrete or continuous random variable?
It's a discrete.
Discrete.
Why? Because we have how many possible outcomes?
5.
5.
In this example, we have 5 possible outcomes. They are countable because it's 5. So then we have discrete random variable. Now, what would be an example of a continuous random variable?
Age.
It's not a perfect example, but income, for example, your income or your wealth, let's say, by the end of the year, because you don't know, right? So maybe you have some gains, maybe you have some losses. You don't know for sure what your wealth will be at the end of this year, right? Right. So that's why it can be anything, right? So it can be 0, it can be something, it can be $1,000 million, who knows, right? So anything, right? So from 0, maybe from negative to positive numbers, anything. So anything on the real number line. So that's why income at the end of the year, this year, is clearly an example of a continuous random variable, but also your GPA. GPA at the end of the semester is also an example of a continuous random variable. Do you agree with me?
Professor, could the GPA be discrete, because you can so the GPA could be on the scale from 0 to 4, so it is still, you can count it, no?
So how okay, let's say 0 to 4. How many numbers do we have on this range? 0
Infinite.
to 4. So can you count? You cannot count,
Nope.
right? So that's why it's an example of a continuous random. Okay, let's say you are, let's say here. Let's say you are here, right? Right now, let's say you are here. But it's possible that it will be 0.56, maybe you are 0.71, whatever, but anything, right? So even from 0.67 to 367 one, even between these 2 points are infinite number of points. Do you agree with me?
Yes.
So that's why your GPA at the end of the semester is an example of a continuous random variable. But letter grades are finite. Sorry, letter grades are countable, but GPA is a number. That's why it's continuous. Do you see what I mean?
Yes, yes.
Very good.
Thank you.
Now, as you already saw, discrete random variables can be given, or maybe in other words, summarized in a table that we call probability distribution table. And that's what we had before, right? But now let me ask you, can we summarize continuous random variable in a table?
I think yes.
Well, then you have to have the very, very long table, right? Because you have to list all of the possibilities, right? So then you have to list infinite number of possibilities. So you don't have time in your life to do that, right? So because you have to be listing all the possibilities which are infinite.
So you said it's a summary, so wouldn't that be discrete, not continuous?
So what I'm saying is that so what you guys already realized is that a continuous random variable takes infinite number of possible outcomes. Do you see what I mean?
Yes.
If you want to give or summarize a continuous random variable in a table, then you have to list all of the possible outcomes, but all of the possible outcomes are infinite for a continuous random variable. Because of that, you cannot do it. Do you see what I mean?
Yes.
Because it is like an impossible task. Why is it an impossible task? Because I mean, if I asked you, for example, count from 0 to infinite. Sorry, count from 0 to infinity. Would you be able to achieve this task? No, because it's impossible. That's exactly what we have finite, and that's exactly why we cannot really summarize continuous random variable in a table. So then what is the option? So what can we do to summarize a continuous random variable?
Sorry, I do have a question.
Okay, so what can we do? How can we summarize a continuous random variable?
Would it be possible to, let's say if we have those grades like GPA, to put in ranges and then have a probability for those? So let's say, what is the probability of GPA being from 3.0 to 3.5? Would that convert it into a discrete?
You can convert continuous random variable in a discrete random variable. That's possible, but that's possible, but that's not the answer to this question, right? So can be summarized in a figure. By a probability distribution function, right? So let's say GPA at the end of the semester. It can take any values from 0 to 4, right? So if your GPA is, let's say, 3.67, it is very unlikely that your GPA at the end of semester will be close to 0, but it can be something here, and it will be very unlikely that it will get anything near 4. So your GPA will be around 3.67 still, maybe here, maybe here, maybe here, whatever, but very unlikely to be here. So this is a probability density function. So here we have f of, this is, let's say, x, or GPA, this will be f of x, right? So what I want to say, guys, is that today I will explain a lot of probably new concepts to you. So don't worry about it, because I'll go back to it constantly and help you understand it over time. And again, I am extending homeworks over and over again until the end of the course. So you don't have to stress yourselves if there's anything you don't understand. Definitely you'll have to work a lot. Definitely you'll have to work hard to do well in this course, but I'll do my best to help you. So if there's anything you don't understand, you don't fully understand, that's fine. Just try yourself, ask questions. I have office hours, and you should be fine. Now, let me summarize. Discrete random variables can be summarized by a table or a figure. We call this table, we can have probability distribution table, or we may summarize the discrete random variable in a cumulative probability distribution table. I will explain all of this later. Same thing here, but instead of table, you say function. So discrete random variable can also be summarized by a probability distribution function, or this will be, okay, or cumulative probability distribution function. So what about continuous? Continuous random variable can be summarized by probability density function or cumulative probability density function. Now, I already gave you example of a probability distribution function for a discrete random variable. Let me copy it. Let me copy this. Print screen. Let me copy this. Let me cut this and paste it here. Okay, this, guys, this is probability distribution table. Right? Now let's draw cumulative probability distribution table. This will be similar, but instead of probabilities, we will have, instead of individual probabilities, we will have cumulative probabilities. Let's say we have this capital X, which is your letter grade, that takes values xi, let's say where I changes from 1 to 5. So let's say x1 is A, let's say x2 is B, x3 is, these are small x's, x3 is C, x4 is D, and x5 is A, right? So that means that we have here our X that takes values x1, x2, x3, x4, x5. And here what we have is probability that it would be better if I start from like, okay, that's fine. Probabilities that X is less than X5. This is not a very good notation, but it's okay. So it's like, so here will be probabilities that X equals X1. Here will be probabilities that X equals X1 or X equals X2. There will be probability, this will be probabilities that X equals X1 or X equals X2 or X equals X3. Here will be probabilities that X equals X1 or X equals X2 or X equals X3 or X equals X4. So what will be here from this table? Here will be 0.20, right? Here will be what? X equals probability that X equals X1 or X equals X2. Probabilities that X equals X1 or X equals X2 is what? This is probabilities that X equals X1 plus probabilities that X equals X2, right? Do you guys agree with me?
Yep.
So that's why we will have here, this will be what? 0.35, right? So what will be here?
0.75?
No, because here you will have what, as I said. So here you have probability that X equals X1 or X equals X2 or X equals X3. So you just need to sum probability that X equals X1 plus, sorry, probability that X equals X2 plus probability X equals X3. So then it means we have 0.20 plus 0.15 plus 0.40. Do you agree with me? So this is 0.75, right? Here you will have 0.75. Then you have 0.85, and there will be 1. So this is cumulative probability distribution table, but this is for discrete random variable. Now let's talk about some population measures. So when we have probability distribution table, so let me, if I have it, no, I don't have it here, but from probability distribution table, we can calculate certain certain measures, right? So one of these measures from let me say from probability distribution table, we can calculate certain measures. Can you give me examples of these measures? Guys, are you here? So examples are, we can calculate the expectation, we can calculate variance, we can calculate standard deviation, we can calculate skewness, kurtosis. Okay, we can then we have 6, right? We can calculate. Okay, so, and yes, please.
Can you calculate average too?
The expectation is the average, average value. You are absolutely right, but we are not yet ready to like fully answer to your question, because average is an analog of the expectation, but average is in regards to the sample, not to the population. This is what I mean, but we will be clear on that later.
Professor, what's number 5?
Kurtosis.
Kurtosis. Okay, thank you.
Now, if we have, yes, please ask.
I'm sorry, is that a C or a K? For number 5?
Number 5 is kurtosis. I will go over this in.
Thank you.
Okay, let me rewrite. This is Kurtosis. I will talk about this, guys. If we have 2 random variables, guys, please turn off your microphone unless you are asking questions. Then we can calculate can you help me? We can calculate conditional, okay, first, marginal probability to conditional probability, 3, conditional expectation, 4, covariance, 5, correlation coefficient. Okay. Now I will go over this in details. Let me start by expectation. This is one of the measures of a central tendency. Let me ask you, do you know another or maybe a few other measures of central tendency?
Mean.
As I already said, mean is the expectation.
Median.
Mode.
Is another measure, that's true. Mode is another measure. So median and other measures, these are another of central tendency are this and that. Median is the middle outcome, right? But this is if you have, if the number of outcomes is odd. But what if number of outcomes, what if the number of outcomes is even? Then what's the median?
The average of two middle values.
Yes. Then the median is the average of the middle two outcomes, right? What about mode? Mode is the most frequent outcome, right? But now let's go back to the expectation. Expectation is an average outcome, is the average outcome. So how do we calculate? Let's say we have this probability distribution table. Let's say this is our random variable x, and this is the probability that our random variable x takes possible outcome xi. Let's say we have x1, x2, and so on, xn possible outcomes. Guys, if I am not clear, please stop me anytime, but also you can also take a look at the, listen to the class recording that I will upload after class. This will be probability that x equals x1. This will be probability that x equals x2, and so on. This will be probability that x equals xn. Right? So what is this, guys? this table?
Probability distribution table.
Now, is X discrete random variable?
Yes.
Okay. Now let's calculate the expectation. Expectation of X, I will have to copy this guy because I will need this table all the time. So let me copy this. Down here. It does reduce the size. Expectation of their random variable X is the weighted sum of the expected outcomes, possible outcomes. And the weights are the probabilities. So how do I write it? It is the sum of every outcome I, where I changes from 1 to the last outcome, the last number of outcome, but I have to weight it or multiply that by the probability that the random variable X takes value for outcome Xi. So this is what? This is just a fancy way of writing this. X1 times probability that X equals X1 plus X2 times probability that X equals X2 plus so on plus X n times probability that X equals Xn. So we will have examples of all of these, guys. But for now, I have to just introduce them, and then we will have examples too. Maybe not today, but definitely over time, we will get everything you are supposed to do from this course. Now, what is the variance? Variance measures the sorry guys, if you are not asking question, please turn off your microphone. Variance is a measure of how far the possible outcomes are from the mean or from the expectation. So the expression for the variance is the following. Variance of X is the formula. Sum of Xi minus expectation of X squared times probability that X equals Xi, where I changes from 1 to the last outcome. So this is just a fancy way of writing this. X1 minus expectation of X squared times probability that X equals X1 plus and so on plus Xn minus expectation of X squared times probability that X equals Xn. So to calculate variance, we need to first calculate what?
Expected or expectations.
Yes.
That's true. That's true. Very nice. Okay. Now let me. So the standard deviation is the square root of variance. So standard deviation, which is denoted by sigma of x, this is standard deviation of x. This is square root from variance of x. Right? Now, what about skewness? First of all, what does it measure? Skewness measures how skewed the probability distribution is. So we may have a left skew distribution we may have a symmetric distribution, or we may have a right skew distribution. Now, if I give you this, is this distribution left skewed or right skewed?
Left.
This is a left skew distribution. Because it has longer left tail. What about this?
Right.
Symmetric.
Now I try to be symmetric, right?
Symmetric.
Symmetric about the expectation. Around the expectation.
Professor,
Yeah.
is a symmetric distribution also known as a normal distribution?
Normal distribution is an example of a symmetric distribution, but we have not yet explained it. But you are absolutely right. It is just one example of a symmetric distribution because there are others. What about this?
Right one?
Yeah. So we have 7 guys. Please attend all the classes, right? So if you can, don't miss classes. So and I think that will help you a lot to do well in this course. Now, how do we calculate? Okay, so skewness coefficient for a left skewed distribution is negative. This is 0, skewness coefficient is 0 here for symmetric distribution. What did I do?
Excuse me, Professor.
Yeah.
You wrote has negative skewness. What? What does that say?
Coefficient.
Yeah, so has negative skewness coefficient. But I have to define this, right? So skewness coefficient for the symmetric distribution is 0, and skewness coefficient for the right scale distribution is greater than 0. Here is less than 0, right? So this is like less than 0. But now let's define skewness. How do we actually calculate skewness? And you will have to do this in the assignment, right? So you'll have to do it in Excel, I think, or maybe whatever. But Excel is very handy. So skewness coefficient is calculated as follows. For the random variable x, it is sum of xi minus expectation of x to the third power multiplied by the probability that x, sorry, you should never mix uppercase letters with the lowercase letters, and I will tell you why. This is lowercase x to the third power multiplied by the probability that x equals xi, where I changes from 1 to n, and divide by sigma, which you already know, right? Because I defined it above, sigma of x to the third power. Guys, am I clear? So to calculate skewness coefficient, you will definitely need what? Expectation, and is it enough? And standard deviation, right? So you need two numbers, two things to calculate skewness coefficient. So if you calculate this, and then you get a negative number, that means what? That the probability distribution is left skewed. So it's like this, right? Now, let's discuss kurtosis.
Professor, I just had a quick question.
Yeah.
Does the skewness coefficient also show like the strength of skewness or no?
Yeah, true. So if it is like a large negative number, that means that it is like, it is wider, longer left tail.
Okay.
If it is like large positive number, larger positive number means longer right tail.
Okay, thank you.
Okay. Now kurtosis. Have you guys heard about this?
Yes.
So can you, if you remember, if not, that's fine. So what do you think kurtosis measures?
It's the sharpness of the peak of the curve.
Okay, that's an okay answer. That's an okay answer. Can you be more specific? It measures the likelihood of the unlikely outcomes. So which means if kurtosis coefficient is higher, means that, so which means that higher kurtosis coefficient means what? Can you tell me? That the unlikely outcomes are more likely. So let me give you an illustration. Let's say we have this distribution. Okay, I don't. Sorry, guys. And let's say we have this distribution. It's a terrible distribution, but it's a little difficult for me to draw. Sorry, guys, but I have to do it.
Professor, can you use two different colors so it's clearer to see?
I see, yes. That's a very good note. Finally, I managed. That's what you do when you just keep going. So let's say unlikely outcomes are the outcomes after some fence. Let's say we have fences. Let's say we have fences. Oh my God, let me. Okay, this is a problem I was facing before. The Word document is sometimes. I unfortunately have to close. Okay, guys, that's okay. We may face some difficulties, but we will be fine.
Press Control S.
I did, but I don't think it will save it. Stop. Window is closed. Okay, it's okay. Give me a moment. Okay, that's okay. You don't see my screen, guys, or do you?
Nope.
Okay. Now you do, right? So
Yes.
it did not save, but it did save some part of it, which is
We're here now.
good. So again, I have to draw it again, but it's okay. So let's do some fences here. Which color is better? I don't know. Let's say it's this one. Let's say this is the left fence. So meaning outcomes below that number are unlikely. Let's say this is our right fence. So that means, meaning the outcomes above that number unlikely. Do you guys see what I mean? I will define what defenses are later in the course. So now, let's do this. So this area and that area, let me call this area 1, let me call this area 2. So area 1 plus area 2. This measures the probability of unlikely outcomes for the white probability distribution function. Do you guys see what I mean?
Can you repeat that?
Now, likewise, this area and that area will be the probability of the unlikely outcomes for the yellow probability distribution function. Right? So, and we have this, right? So this is greater than the sum of the white areas. Do you guys agree with me?
Yep.
So what do you conclude? That the probability of unlikely outcomes are higher for the yellow distribution function. Do you agree with me?
Yes.
Yes.
So that means that Kurtosis coefficient for the yellow distribution is greater than the Kurtosis coefficient for the white distribution. Okay, so it's like higher Kurtosis coefficient means that the probability of unlikely outcomes is higher. That's what it means. So now how do we calculate Kurtosis? Like this. Kurtosis coefficient equals sum of xi minus expectation of x to the 4th power times probability that x equals xi, where I changes from 1 to n. So please turn off your microphone if I'm not asking question. Sigma of x to the 4th power. So to calculate kurtosis, we need to know first expectation and standard deviation. Now let's assume that we have 2 random variables.
Professor,
Yeah,
can you scroll up to the equation again, please?
yes, of course.
Got it, thank you.
2 random variables. So guys, just to let you know, I think, I'm not quite sure, but I will double check it, that the attendance, I think, because it was for the Blackboard Collaborate Ultra, is tracked automatically for this Zoom as well, I hope, and I think it is. Just letting you know. So now let's say we have 2 random variables. Let's say we only have, let's say you are taking, so you are taking eco for 1,000, right? but also let's say you are taking finance 3000. So let's say you have only two possible outcomes, pass or fail. Same thing here, pass or fail. Let's say pass corresponds to 1, fail corresponds to 0, same thing here. So now we can construct, so we now can adjoint probability distribution table. And I will finish today's class after I do this. So we have equal 4,000 and we have two outcomes, right? Let's say equal 4,000, let's say this is x. So this is x equals 1, this is x equals 0. And let's say we have finance 3000. So let's say this is y. So y equals, sorry, y equals 1, y equals 0. So this will be here probability that x equals 1 and y equals 1. This will be probability that x equals 0 and y equals 1. This will be probability that x equals 1 and y equals 0. And this will be probability that x equals 0 and y equals 1. So this table is known as joint probability distribution table.
Isn't y equals 0?
Huh?
Isn't y equals 0 is the last one?
Here?
Yes.
Yes, you're right. So here I have to have 0. Y equals 0. Is everything else correct? Yes, I think yes. So guys, let me stop here. But please don't leave for now. So I will have class. We will have an additional class on Sunday.
Professor,
Yes.
where will you post, download the videos on course section or?
September 6th. Let me give you answer after this. So Sunday, September 6th, 10 a.m. to 11:15 a.m. So if you can, please attend this class. Since we had some technical issues, we want to make up for the time loss that we had to have because of the technical issues. And I'm doing that on Sunday this week from 10 a.m. to 11:15 a.m. So please attend the class. It will be through Zoom and the link is already on the CUNY Blackboard. To answer your question, I will give you guys details how you can access the video that I recorded of this class recording. How you can access this class recording later today. By the evening, you should be able to access it, but I will let you know the details about it later.
I think you could add it to the course section, and that's what my professor did last class.
Yeah, I may do it. I may do it. So I will give you details, guys. So you don't have to worry about that. You'll get everything you are supposed to get.
Thank you.
Now I am trying to see how I can stop recording. Stop recording.